Okay, so question number 4. It is quite similar with your previous question. Okay, for number 1. For number 2, you need to think again a little bit. So we will do number 1 first and we'll go for number 2 next. Okay, so number 1 is very simple. You just have to see the diagram carefully and what property you need to think about that carefully. Okay, so here I said in geometry analysis is very important. Once you know the property, whether you can analyze the diagram and figure out which property or not, that is up to you. That you need to practice, and how I'm showing you and how I'm using the property, you can take the hint from there only. Okay, so see carefully. In figure they have said P is a point. Okay, P is a point in the interior of parallelogram ABCD. So they have given information here. ABCD is a parallelogram. Now you think how you will use this information. First let's see what they have asked you to find. So once I will see what to find, and then I will see whatever information is given, how I will use it to find the solution. Okay, so see, the information till now is given is P is interior point. Now about that I don't know what it is, what kind of interior point it is. So this information is not enough. So let's see. Next information is ABCD is a parallelogram. Now this might help you. Okay, parallelogram, many properties there, so this property I can use to solve the problem. Okay, let's see what they have asked you to show. Show that area of APB. Now the moment you will study the question, try to figure out in the diagram only, that diagram also, that one. Okay, and then see how you will find out. So they have said to show you area of APB, this area, plus PCD, this area, this plus this, and you can see this is a triangle and it is inside parallelogram. So I hope you can figure out what kind of property you might have to use here. Triangle, this is triangle. They say that this plus this must be equal to half of parallelogram ABCD. Just now we have seen a property and I know I have to use that property only here. Why? You can see I have used this property many times, right? What is the property? Inside parallelogram, if you have a triangle which is drawn from same base and inside same parallel, then this triangle area is always half of this parallelogram, right? So you can see this is a triangle and this is a parallelogram. Now I need a construction here, because see, if this is a triangle, single triangle, now if it have to be inside parallel line and on the same base, now you can see this will be the base. Okay, fine, but parallelogram, if you take this one, this is not inside same parallel line. You can see if I draw separately like this is the triangle. If it is this diagram you will consider, then obviously you cannot use this property. This triangle is not inside this parallel. When I say inside this parallel line only, it must be attached with this one like this. So I cannot use this triangle with this parallelogram. So what I have to do is I will draw parallel line here. That I can do, right? If I give you a line, suppose like this, and I ask you draw a parallel line to this, obviously you can do, right? From this point you will find out one distance, same distance you will take from other point also, and you can easily draw parallel line. So same way construction, can I make parallel to this line here? Line, obviously yes. So let's construct a parallel line. See the advantage of drawing a parallel line. If I draw parallel line, you see here this and this line I have drawn parallel, right? Now this and this already parallel because this is a parallelogram. So this and this will be parallel. So see, this will form a parallelogram, right? Now if this form a parallelogram, and you can see this is a triangle under same base and same parallel line. Let me draw that also separately. This is the triangle, this is the parallelogram. This is your point P. This is your AB. Let me name this one now, MN. Okay, MN this will be. So you can see inside a parallel line, this parallel line, you have triangle as well as parallelogram. So we have a property here, area of triangle. This triangle will be always half of this one. So can I write? So first thing, construct MN passing MN parallel to AB. This write down, don't write separately. Okay, there is a lot of gap I have put, so you might be thinking that M and N separately. MN parallel to AB. Let me use symbol only. MN parallel to AB, passing through P. So passing through P, I am drawing a parallel line. Parallel to what? AB. So therefore, triangle APB and quadrilateral, that is parallelogram ABMN, lie under same base, that is base is what? AB, and same parallel line. We have done this one, right? Like this problem I have done in previous question also. That's why I'm writing directly like this, okay? AB parallel to MN. You know that this line and this line parallel, and this triangle lies on the parallelogram, right? On the same parallel line and same base. So what I can write? Therefore, area of triangle APB is equal to half of area of quadrilateral or parallelogram ABMN. Okay, sorry, bracket will be here. Okay, area of ABMN. Sorry for my handwriting. Okay, but whatever I'm speaking here, what I am talking, that you can listen and you can copy down from there only. Okay, and try to understand all this. Forget about my handwriting. So this you mark it as 1. So I have shown that this triangle is half of this. Now what I will do, similarly I will write this is, because see this, if it is parallel to this, and we know that this and this parallel, right? So obviously this line will be parallel to this also. So this also will form parallelogram, and this triangle is under same base and same parallel line, you can see. So here also I can write this triangle is half of this. So as a whole, this plus this must be half of this plus this parallelogram, this plus this, right? This one is half of this one is half of this. So this plus this must be half of this plus this. Okay, so that's why this one I have marked 1. Similarly, I will write triangle or area of triangle PCD is equal to half of area of quadrilateral MNCD. Okay, so this you mark it as 2. So adding 1 and 2, what you will get? Area of APB, yes, area of APB, triangle APB, plus area of triangle PCD. Okay, this one I have put bracket outside here only, right? Quadrilateral I have to put. Anyway, you have understood only, right? You have used this symbol mainly. Let me write properly this one. Area of quadrilateral or parallelogram ABCD. You can simply write ABCD also, okay, without giving the symbol. So this side plus this side, left side I have added, right side also I need to add, right? And this I told you why it is equal, right? With the example of number also I have taken. 2 if it is equal to 2, 3 is equal to 3. If I add left side and left side here, right side and right, then also it will be equal. So same logic here also, okay? So half of area ABMN plus half of area MNCD, which is equal to half. Can I take common? Now area of ABMN and MNCD. Sorry, I should write N here, M here, right? So in sequence you need to go, okay? ABNM and plus MNCD. So this plus this, what it is? Can I write ABCD? Area of ABCD. Okay, so this and this you can see the same. Okay, so this is your proof for first part. For second part I will show you tomorrow. Okay.